Hey, Mike.
Hey, Martin, how are you?
Not too bad yourself.
I'm good. I'm looking forward to this next few minutes to talk. I'm looking forward to the conversation.
Absolutely. I'm curious how this will compare to some of our chats that we've had on panels and on Clubhouse. This particular format is always interesting to me.
Yeah, and I just I enjoy it for sure. And I really hope we're looking forward to seeing what questions the audience has for us as well. I think that's always fun to see what these sorts of conversations trigger in other people. You know.
Well, yeah, what I find is interesting is getting people to attend from around the world. In some ways, a lot of the differences in manufacturing are sort of more evident to sort of move up at the managerial level. When you get down to the machines, there's a lot of similarities there. That's always neat to see. So I see people are starting to fill in the room here. We'll give it a
Yeah,
couple more minutes, and then we'll flip it over.
that sounds good. Yeah, we'll see. Get most people in the room.
Yeah, so maybe we'll give it one more minute here, and I'll flip it to. So why don't we go silent here for a couple of minutes, Mike, and then let me just get to the next slide here. So we'll turn off our screens. Hi, everybody. Welcome to our webinar today that I'll be hosting with my good friend, Mike Ungar. Today, we're going to be discussing digital transformation, as well as some of the things that organizations can do to maximize the chance that it's done successfully. And one of the things that Mike and I always like to discuss is sort of the human aspects of digital transformation, which are often underemphasized. Hey, Mike, how's it going?
Hey, Martin, good to spend the next half an hour, 45 minutes with you.
Absolutely. So just a quick, we won't go too long here, but as mentioned, Mike's a good friend of mine. We collaborate on many kind of Industry 4.0 initiatives. My background's in manufacturing and tech. I spent my early career on the shop floor, so I'm very aware of kind of the experience of operators and the kinds of things that make them reluctant to adopt new technologies, as well as the ways to deploy technologies in a way that can benefit them as well as organizations. Mike, why don't you give us 15 seconds on your background here?
Yeah, thanks, Martin. So I spent a few years in the Army and then joined Michelin North America. During my time at Michelin, I worked in continuous improvement, led operations teams, did a little bit of finance work, as well as HR. When I retired about 18 months ago, I decided to continue my focus on helping others, and I became a coach. So that's what I want to do today.
And one of the interesting things is that we both started our careers on the shop floor, engineers getting put into sort of frontline supervision roles, and I think that's I think for anybody who's now in tech or in consulting or working at an executive level, that early experience working with operators, building the stuff is a pretty unique experience and often a bit shocking for those of us who come from engineering background. So just as we jump in here, I want to set the frame. Manufacturing today is not quite as it was when Mike was on the shop floor or when I was in the shop floor. There's a lot of challenges that manufacturers have to face today that are making it much more difficult to compete. So supply chain volatility, creating plans that you can look 2 weeks ahead of time and know what kind of resources you need, all get thrown out the window when you don't know what kind of parts you'll have available. It's harder and harder to get people to work in our plants. The labor shortages are, again, making it hard for us to plan, making it hard for us to minimize overtime, and ultimately hard to keep up with demand. And finally, and we all see this based on our buying experiences during COVID, all of us expect highly customized goods to be delivered with very short lead times. So if you combine all these forces together, what it takes for manufacturers to compete today isn't the same as what they needed to do 5 years ago, 10 years ago. So things are changing. And the consequence of all these challenges is that manufacturers are struggling to make sure that they are using all their time productively. So there's what it takes today to be competitive is different than before. So maybe just set the groundwork here and from a data perspective, in manufacturing, the kinds of data that are available and that are used have been the same for a long time. And this is the same as it was when Mike was on the shop floor. Mike, I used AS400 terminals. I think maybe you may have used the same actually.
Well, we started with, I think about the shop floor, we started with Silamog managing our machines. And it's interesting when you put the stack up, Martin, because, a lot of us, this wasn't, we didn't think this way or start this way, but, you added these things incrementally over the last 40 years. They didn't just all happen at once,
Absolutely. But, these are all the basic things that you have in your plant. You have your sensors, your PLCs, you have your, controllers, and then planning and ERP, and maybe a couple of those for some manufacturers are Excel, but really, the way that manufacturers have been managed traditionally and the way that many are managing today is you buy software packages or technology packages that connect to one level of the IT OT stack. You have humans in the loop, which make it so that you can, draw reasonable conclusions and create a plan. And I think this is what we've relied on for a long, long time. So now with some of the challenges that I mentioned in the previous slide, we have to be much more responsive, much more resilient if things are changing that quickly. So the promise of Industry 4.0 is to connect all of these elements of the IT OT stack together in real time, so that rather than optimizing for what's happening on the shop floor or for planning or for financial, you optimize for one thing at once. You optimize for the success of your business, which intuitively makes a ton of sense. And that's why manufacturers are racing to adopt new technologies. But one of the things here with all of the investment over the last few years, last year, $120 billion were spent on Industry 4.0 solutions, and it's growing at a very quick rate. You'll notice on the left-hand graph that labor productivity is actually not increasing. So despite increased investment, labor productivity is actually flatlining. And a lot of these projects that we're initiating are not successful. And in addition to these projects not being successful, almost most shocking is close to 70% of people in the plants don't trust the conclusions that are being drawn by these technologies. And in some ways, wasted investment is unfortunate, but losing the trust of the shop floor is critical and extremely important to frontline or operational performance.
Martin, the other thing I noticed on this graph that I think is interesting too, especially for companies that manufacture in Western cultures where labor is more expensive, is if you're not getting the ROI on your investments, you're really putting your factories at risk. Obviously, we've got to continue to be more and more productive, and this is really telling and quite concerning if you happen to be one of those folks that's not getting the return on your money.
Absolutely, and I think there's a point now where everybody's investing. And now, if everything was the same for all, where nobody was getting returns, I think then that nobody has an advantage. But more and more now, people are realizing what it takes to successfully digitally transform, which is part of what we wanted to discuss today.
Yep.
So one of the things, if we talk about technologies that use data, all of them have different permutations of what's shown on the right-hand side here. So you have a manufacturing process. You gather data from that process. You clean that data, which if you're using historical systems, often is done, by people. And then once you get information, you can perform analytics and modeling, and ultimately improve how well you control this. So this diagram from SESME on the right-hand side captures the general, way that data is used. Now, the areas that are a challenge for many are the areas that are often, it's unclear the importance of this when you're doing it with software. If you are doing analysis on your own, seeing bad data is super evident. But if you purchase technologies, it's not always clear that the data is good or bad. So ultimately, all of these systems rely on the quality of the information produced. And this is one of the areas that many Industry 4.0 initiatives are struggling with, how to get accurate information. And this phase, the phase between data and information, the contextualization phase, is one of the most complex and underemphasized portions of this loop. And there's two issues that are causing this contextualization phase to get done ineffectively. And the first one is we showed the elements of the IT/OT stack in the previous slide. Many of the systems that currently exist to provide value to manufacturers don't connect into all those different elements of the stack. If they are a planning software, they may connect to your MES and your ERP and maybe get some shop floor data, but never a full picture. So they don't get data from all of the different areas of the plant, despite the fact that that's the promise of Industry 4.0. And the second thing is that often the context from people is missing. And for any of you who have worked in manufacturing, you recognize that the data you have in your Excel file only captures a small portion of what's actually happening on the shop floor. And I know Mike has some thoughts here, but if you want to truly understand what's happening, you need to go down to the shop floor, and there's context that people have that is extremely important to actually understand what's happening on the shop floor. So human context is missing. So if you combine the fact that the data being sent through these systems or the information that's being relied on from these analytics platforms is of questionable quality, what happens is that people become disillusioned with the fact that they have these systems that aren't capturing their actual performance. And not only are they disillusioned from technologies they don't trust, often people on the front lines are being asked to feed these data systems with burdensome and complex systems that require that they pump in more information because of the recognition of the importance of information. And I'm curious to get your thoughts, actually, Mike, on sort of some of the challenges that we're facing today with regards to this.
There's no question, Martin. Just because we have a lot of data, and the system today can bring you a lot of data, if you're not getting that context, the actual observations, you're really missing out. One of the first things that we used to teach our industrial engineers and progress engineers at Michelin, literally the first day you're at work is you go to the shop floor and you do an observation in order to understand the facts and then look at the data, not the other way around, because we can really get enamored with the data and miss going to the floor and get the facts. So your point's really true. That without taking that time, that poor contextualization and getting that, you're not going to know the root cause. You're not going to be able to find the root cause of the problems that you face.
And I think, you and I both got to the shop floor with a background in engineering, and often in the early days on the shop floor, you get pulled aside by the plant manager, usually when you're excited about some piece of data that you found in some graph or some chart, and reminding you that that's not reality. And reality you need to go to the shop floor, speak to the operators, see with your eyes to understand what's actually happening. So that context is critical. And the fact that context is important. Taiichi Ohno, the father of lean, captured this, many decades ago. There's a difference between data and facts, and facts are what was actually happening on the shop floor. We have plenty of data. Now, what's important is how do we find that data that helps us understand what's most important in our factories.
Yeah, and just to comment on you see that today. If you go into a Toyota factory, it is part of their culture, and you can see it ingrained in the managers and the folks working on the line. So it's absolutely true.
And in some ways, with technology, the way that it's being deployed today, in some ways, is pushing people away from the shop floor, where, in effect, if the net result of your technology deployment is that your leaders are spending less time on the shop floor, that's likely going to result in poorer performance.
Yeah.
Really, we should be using technology to unburden our leaders from things like data tasks that they're not good at, so that they can spend more time doing what they are good at, which is collaborating to solve problems.
Exactly.
So first off, contextual time. We need to understand what's actually happening. We need the facts. So I think the idea that these facts come from people is, extremely intuitive. Now the question is, how do we get facts from people? And people are different than machines. You can't instrument a person. In order to get people to collaborate with us, we need to create engagement. So now, and there needs to be some sort of return for their effort. So if we need context from people, we need to give them something in return. So the best thing that we can give people is better awareness. So one of the things that we have now, if we actually know what's happening now and know what's happened in the past, we can provide this information to people in real time, which help them to understand what's happening now. Where are they on their production? Are they going to miss? Are they ahead of schedule? Or are they behind schedule? So better awareness is something that we can provide to them once we have better context. And if they are more aware, we can create better engagement. And ultimately, better engagement is kind of what fuels most healthy, or fuels all healthy continuous improvement cultures. And you see that this is a loop, because the better engagement we get from people, the better context we get, and the more that we can identify what's happening in real time, that we can identify that they're losing time because they're waiting for maintenance, or losing time because they're struggling with a setup. So really, this loop is key. And what's also important is that there needs to be a clear high return on effort. So operators can't be expected to spend all of their time feeding these data systems. So lots of awareness, a little bit of context, and ultimately we should be trying to focus and control engagement, or improve engagement. So if you have a timeline like I showed there, which is basically capturing contextual time, and you understand how time is spent, there's two things that you can do. You can stop inefficiencies as they happen. So back when I was a supervisor, I would try to hunt for inefficiencies by walking around. I had 50 operators in Montreal, and I was somewhat effective at finding them. Like, I was a pretty fast walker. But ultimately, if I were to think about value that I could provide to that supervisor, where is the problem that I should be solving right now? So number one, solve inefficiencies as they happen. And two, if we actually know where our inefficiencies are over time, that's how we should be guiding our engineers to work on our most important systemic inefficiencies. But it all starts with that timeline. It all starts with the fact that we need to understand what's happening now, and we need to understand what's happened in the past, and that data needs to be complete and accurate. So now, once we have this complete and accurate timeline, and say you're an engineer, as I was early on in my career, if we see our problems and we're now assigned to invest our time or invest money to solve these problems, we can now pull out the right tool for the job. So if for machine issues is actually your biggest issue, you can look to see if you can get big data or AI to help predict machine failure. There's lots of technologies out there that do that. If your issues are more operational, where you have issues waiting for resources, there's neat mobile and cloud technologies that can help with that. Or IoT to monitor machine performance, augmented reality, which is really neat to help make training easier, which is a big challenge for many organizations as you're bringing on newer and newer. And I know, Mike, training that's one of your areas of focus for much of your career.
Yeah, no, it's absolutely true. And we used to have to train offline, and now with augmented reality, you can it's almost like you're online to do that, and you get guided help. It's really fantastic.
And I was chatting with one of our clients recently, and he was describing how in the past he used to take for granted that people would be in their jobs for 5 to 10 years. So you would have a particular training approach, and you'd hire people that were experienced. And now more and more he's having to hire people straight out of school, and expecting them to stay a year and a half, 2 years. So now you need to come up with a training program that gets them up to speed very quickly, and then also understands that this will only be a stop on their career rather than their main career. So augmented reality, the idea that we can actually share best practices much more easily is really exciting. I don't know if I've seen it in many plants yet, but that's the kind of thing where, for organizations to get value from these technologies, you need to make sure to pull out the right tool for the job. So
Yes.
If you're going to say something, Mike.
No, I was going to say the other part of augmented reality that's really helpful is that it reduces the training time tremendously. And when you get that can often drive your productivity quite dramatically as well.
Absolutely. So, and then of course robots, right? So at some point, if if you have an issue where it's can clearly be solved by autonomous robots, replenishment, for example. The key thing here is before investing in that technology, if you don't want to have your technology on the pilot purgatory pile of failed Industry 4.0 initiatives, you need to make sure that you are solving an actual problem, and that's so key. And that starts with something which seems relatively simple and mundane, which is just to simply understand how you're spending your time and resources. So that's what we do at Raven. We help our clients capture what's happening on the shop floor. We get that complete and accurate timeline that describes, the time that's spent properly and productively producing on setup, on breaks or meetings, and time that's lost either slow producing, slow setup, or other things that are clearly losses of time here. And understand that the formula for getting that accurate timeline starts with engagement. Engagement is what actually makes it where if you have that accurate timeline, people will take action. And the way to drive engagement with operators is there needs to be a high return on effort. If they use that technology, and one of the things I also always like to sort of contrast is consumer technology compared to industrial technology. So with consumer technology, if the operator or if we don't like what the app is doing for us, we just uninstall it. And if we don't see that there's a good return on our own effort, and in manufacturing, in many cases, organizations take for granted that technology can be mandated, and they just have it as part of their process, or call it part of training. So ultimately, the goal for all technology should be something where anybody using it, it should be clearly obvious why they're using the tool. And the tool or software or solution should provide a high return on effort.
Martin, looking at what the Raven can do for you, back when we work on the shop floor, we would have the operators capture the data, and then they would provide also the context, and that took a lot of time away from producing. What's really great about this is it makes data capture much easier, quite simple for the operator. And then they can focus on the context and getting the facts we really need to get to the root cause and solve the problem. So I really appreciate what you're sharing here as a really great approach to driving progress on the shop floor.
One of the things, I think this is clear, the more experience you've had working on the shop floor, the more clear it is that we effectively need to stay out of our operators' way. If everything is going fine, the last thing they need is for technology to be slowing them down. And the only use of technology to them is as a way to apply pressure to their leaders in the organization to work on the right things. So in order for them to do that, they need to recognize that the tool and this technology is intended for that purpose, is intended to apply pressure outwards and not inwards. And the second thing is that respect for their time. The last thing you want is technology to be added to that group of lost time on the right hand side. And in many cases, if you're having to fill data in Excel, like there's a whole bunch of wasted time transcribing and copying data from one source to another. So, and ultimately, once you have better context and you have better engagement, you can get better performance. One of the things I'll highlight here is the fact that once you get complete and accurate data describing how you're spending your time, often the areas that are the biggest opportunities are operational losses. So these aren't the things that you would necessarily think were your biggest causes if you are looking exclusively at machine data. So waiting time is something that comes up again and again. Time where operators are waiting for material, or waiting for somebody to move a pallet, or waiting for their supervisor to come inspect a part. This is time that is lost, but that's almost lost in the mix of PLC data and other things that are more obvious as sources of data when you're looking at data through Excel or through your data system. But these are things when you walk to the shop floor are so obvious when you see that somebody scratching their head with a pallet blocking their machine, kind of wondering what they do next because they're and I see you laughing, Mike, because I'm assuming that you've experienced this.
Yeah, but looking at what you share on the slider, what it also makes me think is that when you really understand, where you really have the contextual information about why the delays, why the process is less performant, the solutions are normally quite simple. And you see things like better shift changes. Well, that's easy. That's a simple organizational thing in communication with the associates on the floor. So there are so many simple things to go do once you know that those are the root cause of the problem.
Absolutely, and I think maybe the idea that you can use advanced technology to identify simple things to fix is not intuitive. I think often we and this is also the fault of many of us who are who speak about the future of Industry 4.0, or we're excited about truly interconnected systems where your sales are connected to your operations seamlessly, and so we're not there yet. So there's no shame in identifying opportunities for early wins and looking for early gains. And actually, that's mentioning that the challenge of trust. That's one of the ways to establish trust by showing people that there are simple, practical ways to use technology to drive gains.
Yes, and also using that information to ask the operators, what problems and opportunities are your priorities, and going after those quick wins based upon maybe their priorities to start to gain their engagement and their buy-in to the technology.
Absolutely, and just before we jump into the Q&A here, and for the Q&A, if you guys have some questions, please post them in the comments, and Mike will read them out after we go through the section here. But ultimately, when it comes to digital transformation, we need to move at the speed of people. Transformation. We often think about technology and interoperability between different technical tools, but technology can be switched on with a switch. Figuratively, we aren't that simple. People don't like change, so we need to go be deliberate about it. So as we are. If you are embarking on digital transformation, first, we need to prioritize frontline engagement. In some ways, if you have that org chart at your organization, flip it upside down and then work from the shop floor out. We need to make sure that people at the machines running our processes understand the value of the technology that's being provided. If we can create engagement at the shop floor and throughout the organization, that's and again, when I say start from the shop floor, none of this is possible without engagement from leadership and support there. But focusing on making sure that there's recognition of the value of these technologies. The second thing is incremental. Digital transformation doesn't need to start where you rip everything out and install a whole bunch of new greenfield opportunities for these kinds of deployments are exciting, but not practical. At some point, we need to find a way to continue to run our businesses while embracing these new technologies. So start small. If you focus on number one, it's intuitive that you should be looking for small wins and points where people, you almost see that spark in their eyes, saying, "Oh, I get it. I see how, this is providing more value." Earn the trust of the front lines, and you can't earn it with a training session. You need to earn it with the reality of their day-to-day, and they will recognize when something is clearly providing value to them. And interoperability. So I mentioned before the risks of rip and replace strategy, where you're basically starting from scratch. That IT OT stack is still there right now, and 10 years from now, many of those elements will still be there as well. Like in manufacturing, we're not the type to take a machine and throw it in the garbage just because it isn't the latest version. So we're going to have to deal with this, what we've been relying on for a long time, and that's fine. And I think the key thing here is that no one provider is going to provide all of the things that manufacturers need to be successful in the age of Industry 4.0. Technologies need to continue to evolve and find providers that can play nicely with others, and providers that understand that this is not the next a journey they go a stepwise journey. It's a continuous journey, and you want to find vendors that can collaborate with one another. And actually, I'm curious to get if you have any final parting comments, Mike, before we jump into questions.
No, Martin, I think it's I really appreciate these 3 takeaways. I think they make a lot of sense. One of the principles when I think about lean is operator engagement. When you're dealing with change, the idea of small, quick wins makes it a whole lot easier rather than big, massive evolutions. And then again, finding partners. No one has all that knowledge inside their business. Finding partners to join the journey with you. Those are all three really key takeaways. Thanks for that.
Absolutely. And I think with regards to engagement, I just, I'm thinking just the look the look of my operators looking me in the face when they're either like impressed or not impressed with me. And I would say there's probably many times where they weren't impressed with me. And I think that's something that you can only experience firsthand on the shop floor. So if you're showing them something and they get it, you see that nod, you see that spark, or you see that those eyes glaze over and the eyes rolling. And I think that's something that, you need to be there in person to experience. And I think that feedback that you get while being on the shop floor is critical. And with regards to technologies that pull us away from the shop floor is going in the wrong direction. If anything, we should be able to spend more time on the shop floor with our teams if we get the right technologies.
So Martin, maybe I can jump into some questions here that have come through for us. And this comes from Sandra. She asks, do you have any data that says how much time or how much less waste there is as a result of leveraging Raven's tools?
It depends on the client. And so we have some clients that have saved, there's one of our, so yeah, absolutely. We have plenty of business cases capturing time saved. One of our good clients in California, Danaher plants, saved close to 500 machine hours per month by addressing an issue with waiting for maintenance. So what was happening is that the machines were going down, and it was taking a while for maintenance to get to the machines, and not because they weren't didn't want to go over, just that the information it wasn't clear that was the big issue. So by getting contextual time and understanding how time was spent, it was clear that waiting for maintenance was their biggest issue. And in several months, they reduced it from 600 machine hours to less than 100 machine hours per month, where each machine hour was about $1,000 of production capacity. So we're talking millions of dollars of top line revenue increase, as well as significant hundreds of thousands of dollars of saved labor cost by addressing an issue as mundane as waiting for maintenance.
Well, thank you for that. So another question from Laura. Laura asks, systems like this often take a long time to get up and running. What's the burden on the organization to get something like this going?
So I think like the burden of the organization depends on how quickly you try to deploy new technology. So one of the things here is that we often recommend starting simply as simple as possible. So for example, to deploy our technology on one line can be installed within a matter of days. And often we follow a similar methodology to how you would set up say a whiteboard on the shop floor. So one of the things with whiteboards is that it's very intuitive. People understand as you're building the different components of it. So often our first deployment of our technology will have very few different tags to describe why the machine is stopped. And the reason for this is to get operators to begin to understand the basics of technology and get to that moment where operators push back and say, you know what, I'd actually like a few more ways of describing what's happening, because they understand that this is a tool to describe their day. And if they don't have all of the right ways to describe their day, they're going to push back. And that moment where operators take the wheel and say, hey, you know what, I think I see a better way, and ask to bring in functionality, that's the key thing to create acceleration of all this. And really, so the burden on the organization depends on whether or not you see at the finish line and try to deploy it instantly, or you approach it as a journey where you try and bring your operators along the way.
Well, thank you, Martin. This comes from Alan, so it's a little bit long. So I'm going to read it and give me a second here. So one pain point I often see is that junk data is identified as something to collect, but in order to push back, the operators need additional data to explain the lack of the value gained by the data they actually were capturing. So at the end of the day, this is time and effort operators don't have as their mandate to produce, as their mandate is for production, as you can imagine. So his question is, are there any recommendations for how shop floor operators can effectively push back against needing to capture poorly contextualized data?
I think one of the key things here is that there needs to be a collaboration from the shop floor leadership from the get-go. And if at any point, leadership sort of hands off responsibility to the organization, that's a risk to any of these deployments. So, one of the critical things that happens early on is that there needs to be agreement that what is being claimed to be the truth is actually the truth. And this means that if you're showing that timeline to operators, they're nodding their heads. And if you're showing the timeline to production supervisor, they recognize it to be true. And same thing for senior leadership. And typically, if it's done properly, there's a certain thing that often happens where you see the operators with a sort of a dry smile, they're nodding their heads, and the plant manager, because the operators basically, if it's done properly, there's a bunch of "I told you so's" in there. Operators often say, like, I've been telling you that this is a problem, and to have the ability to actually capture with data. So I think the foundation and many, before jumping to metrics and before jumping to objectives, the first objective is to simply assess, do we actually know what's happening now? Do we know what's happened in the past? And get everybody on the same page. And that's the starting line. And I think what Alan is mentioning is what happens when you skip that starting line and you jump to the middle. And I think that's the risk. So you need to get that nod, and the operators are going to be smiling because there's going to be stuff in there that they know that others don't know. But that's the first step, and you can't skip it.
Yeah, I think that it can really that really resonates, this idea that if you don't define the problem correctly at the beginning, you don't have the real information, you're never going to solve the problem.
Yeah, PDCA. What was that? 1950.
Yeah, absolutely. So another question from Sandra that's interesting. I'm interested to hear your thoughts on this. Where or how does all this work with AI fit into what you're talking about? Because AI is coming more and more to manufacturing.
Absolutely. I think AI is coming into manufacturing in a bunch of different areas, and given the issue with the quality of information I described earlier, the higher up in that IT/OT stack that you go, the riskier it is. So if you're using AI to predict planning, or AI to predict financial performance right now, because of issues with information quality, those are much riskier applications. So the points, if you're looking for areas where AI are being most successful now, they are further down in that IT/OT stack. AI used for vision systems to identify issues with part quality in ways that we couldn't do manually, and inspect 100% of parts. So if at Raven we use AI to help contextualize time. We use AI to help make it where we don't need to ask operators what's happening every single time the machine goes down. So we use it to reduce the burden on operators. So I would say, if the AI is now effectively, it's an approach to help identify patterns and anomalies that's highly effective, but it's very dependent on the quality of information being fed into it. So right now, if companies are looking to apply AI, I would focus on at the bottom of that IT/OT stack, which is sensor data, machine data, and we're at Raven, we're in the middle where we use it to contextualize. I don't know if that answers that question precisely, Mike, but
no, I think that sounds great. No, I think that makes a lot of sense. I just want to ask the participants with us today, if you've got a question, drop it into the Q&A so we can make sure we get to it. I've got just one or two more questions, Martin, for you. This comes from Steve. One of the things that's interesting is Steve says he works in a discrete manufacturing environment. Does this work also in continuous manufacturing as well?
Or continuous flow? Absolutely. So
yeah, because there's process.
Yeah, so I think in discrete manufacturing, the meaningful timeline is the timeline of what's happening at that process. For continuous flow, you need to identify the constraint of the process. So, and to identify the constraint of the process, ultimately you need to have that timeline for each of the individual components, and then use a strategy like theory of constraints to identify what is in fact the constraint. But generally that approach to find the most important part of the line and see how time has been spent is universal. To get to the point where where to instrument is a little bit more complex for the interconnected lines and also for manual processes. So basically the approach at the end is similar from an operator perspective. To understand where to focus is somewhat more complex for interconnected lines.
Oh, thank you. One last question then. So if you're not sure where to start, do I try to convince the operators, the supervisors, or the plant manager that this stuff's good stuff? How do we get started?
So it all starts with leadership, and at some point there needs to be leadership commitment to continuous improvement. A lot of the things that need to be in place for companies to successfully digitally transform have nothing to do with technology and have to do with the way that their culture is set up and how much they are dedicated to continuous improvement. So yeah, it needs to start with leadership, but then for it to be successful, leadership then needs to flip that hierarchy upside down and then make sure that everybody's bought in. And the style, servant leadership style is one that Mike, you and I chat about frequently, and that style is quite effective when looking to deploy new technologies and manage digital transformation change.
Well, that's all the questions that I see, Martin, in the Q&A. Or any final thoughts here, I guess, before we wrap it up?
Yeah, I want to thank everybody for tuning in to listen to us. Mike and I, been friends for a while here, and we always enjoy talking about digital transformation and technology. I think one of the things that we always like talking about is the human aspects of that. And I think I always remember those first few weeks on the shop floor, coming from engineering school, where my experience was completely different from what I thought it would be coming from school here. So I have a deep respect for manufacturers and the challenge on the shop floor. And I'm fortunate today to be able to visit plants occasionally. I'm not quite there all the time, and I know, Mike, you and I have chatted about that many times.
Yes.
And Mike, I want to thank you for joining me here today. It was a great chat as always. Any parting thoughts?
I really enjoyed the conversation. Ultimately, what we're talking about, what you've been talking about throughout the session, is marrying technology with people and ensuring that the people really drive the use of the technology to get business results. And I think that and solve problems. So I think that's wonderful. And so I appreciate the opportunity to engage with you on it. Thanks.
Awesome. Thanks all.